This is the ThinkBooster Visual Debugger, an interactive tool for comparing test and compute scaling strategies side by side. It lets you see how different search strategies explore the reasoning space and how scorers like process reward models evaluate each step. We start with a cached example, a conditional probability problem. A box contains 5 red, 4 blue and 3 green balls. 3 balls are drawn without replacement. Given that at least one ball is red, what is the probability that all 3 balls are different colors? Express your answer as a fraction. We see 5 strategies compared: baseline, self-consistency, online best of n with param scorer, beam search with param scorer, and offline best of n with param scorer, each making a different quality compute trade-off. Let's click on beam search. The reasoning timeline shows how the model explores step by step. At each step, the PRM assigns a score, and the search expands the most promising candidates, as you can see on this trajectory tree. We can inspect individual reasoning steps and see exactly where the model commits to its approach. Now, let's switch to a harder problem, finding the smallest positive integer satisfying 3 modular conditions. Here, beam search runs for more steps and uses significantly more tokens, a deeper exploration than the previous problem. The process reward model, assigning its scores, guides the search through a more complex reasoning chain, so we can see details and inspect each step using Step Inspector. Looking across strategies for this problem, baseline solves it in one shot, while beam search uses thousands of tokens for multipass exploration. Self-consistency generates 8 independent paths and takes a majority vote. Offline best of n generates all trajectories up front, then scores them with PRM. For example, we can consider step 7 from the path 4 and see that PRM scorer assigns score 0.996. Each strategy makes a different trade-off between compute budget and verification depth. Now let's run a strategy live. We switch to custom input, select an open router model, choose beam search with PRM scoring, and set budget to 8. We type a new question and click run. So we can see the initialization of PRM scorer. Now we can see that reasoning tree is started to be generated. So the button shows real-time progress, generating candidates for step 1, for step 2, and so on, as the strategy explores. When the run finishes, we see the full result with PRM scores for each reasoning step. The run is finished, and we can analyze this trajectory tree in details. We can see that PRM score assigned to each of these nodes its own score. For example, you can see it there through Step Inspector. You can analyze what model generated there, and then see final answer, 63. The visual debugger makes test and compute scaling strategies transparent and comparable. You can inspect cached results offline, run live experiments with any OpenAI compatible model, stop runs mid-execution, and see exactly how process reward models guide step-level research. It's designed for researchers who want to understand and iterate on inference time scaling strategies.